in the other part is going to move because it's rolling in the ground. And the pin one, and the fixed one is going to be reaction everywhere. Like we are going to have moments, we are going to have vertical or horizontal reactions. So it's like it's a little bit more complex for the other, compared with the other ones. This is going to be posted on the web courses, so you don't need to take some notes about this. If you want to take your notes, it's okay. But so this is the first problem that we already have with the simplest one. So we got this beam, and we got a triangular load here, and we got a punctual load here. So determine the result internal loadings on the cross section through the point C. So we have to analyze the point C, and to obtain the load is in the internal loads in that part. So first we have to do a free body diagram in order to be sure what are going to be analyzed in this part. So to obtain the resultant force or the vertical force in Y, we have to do a summation of moment in B, and we have to consider all the loads that are here. So right now we get a negative load here, well, a negative moment here for AY, multiplied by the longitudinal part or the distance that we have between A and B, and this is this number here. After that, we get a punctual load here with his distance to the point B, and we get a triangle force that is going to be obtained by the area of the triangle, right? That is 3, that is here, times 2 the base, that is 3, 2. So we have 3 times 3. Divided by, and we are going to multiply by the length, that is going to be 2, and divided by 2. 2 is because it's going to be the area. 3 times 3 divided by 2 is that triangle. And the length and the distance between the point that we are going to apply the load and the point B is going to be 2. So we can obtain right now AY, that is the vertical load that we already have in the point A. And after that, we can do a free body diagram about this section here in order to get the forces in this part. So we got a moment, we got an axial force, we got a vertical force here, or a shear, and we got vertical forces here. So for the axial, for the longitudinal force, we are going to know that force, the summation on Fx is going to be 0, and we don't have any load in the x direction. So the answer for this in the axial load in the point C is going to be 0. So after that, we have to obtain all the summation of forces that we already have here in the body diagram, the free body diagram, and we already have the force that we obtaining for A, the force that we have in 6, and the force that we want to obtain in C. So we already obtained that the shear force or the vertical force that is going to be applied in this part, the internal force, is going to be equals to 1.5. Do you have any question about this? I'm trying to do very fast because this is very, very easy. Yeah.
We didn't need to do the triangle load, did we?
We got the triangle force here. We need it because we have to obtain the vertical force in the A. So in order to obtain, we have to do moment in B. We have to do moment in B, and we are going to have this force here that we don't know. We are going to have this punctual force here that we know, and we are going to have a force applied at 2 meters from B that is due to the triangular force. So that's why we have to consider the triangle. Another question maybe? Okay. So it's very simple. It's just, I think it's the basic part of the study. So we can obtain the moments with the same procedure that we already did before, but in this case, we are going to do it for C. So we can obtain the summation of the moments in C that is going to be equals to 0. So we are going to have a force here and a force here that is going to give us the moment in C. So we got the moment in C that we don't know. We got the punctual force here that is going to be located at 0.5 meters. And we got the reaction in A that is going to be located at 1 meter. That is going to be 7.5 that we already obtained in here. So our moment in C is going to be 4.5 kilonewtons per meter.
Yeah, for that, you're just working off of the small free body diagram.
Yes. Yes, this body diagram that is here, the figure B, that is this small piece here. So in order to analyze the element, you have to divide it by segments, depending on what you want to watch in the element. So in this case, we first analyze the entire element in order to obtain the reactions. And after that, we proceed to analyze the element in the point that we want to analyze or to obtain the forces or loadings. This is another one that is very interesting. I try to take big examples and be generalized about the examples because we got a lot of examples of this. So this is like a review, so it's very fast. So we got this structure here that is going to be a frame. The pins on the frame at B and C each have a diameter of 0.25 inches. And if these pins are subjected to double shear, that is the example that we have here, the figure that we have here, determine the average shear stress in each pin. So we have to obtain the results or the average stress, shear stress in these two pins. So this is the example that we already have. This is the double shear that is going to be like a sandwich of the elements. So it's like this. We are going to brace this element here, or this one is going to brace these ones here. So we are going to have like two elements here and the other one is going to be in the middle. So first we have to do the body diagram that is like this. Is simplifying these elements here. And after that, we are going to obtain the reactions in the body diagram, considering a moment in E. So we are going to do summation of moment. This is not E, this is not G, this is E. So we are going to do summation of moment in this point. And with that summation of moments, we are going to have a load here multiplied by the distance, that is this one here. We're going to have a load here multiplied by the distance, that is here, right? And we are going to have the reaction in D, in the D point, multiplied by the distance that is here. So doing all of this computation, we're going to obtain that dy is going to be equals to 650 pounds. After this, we can do the summation of forces in X. That is going to be this reaction here, and we have to analyze what kind of connection do we have here in the structure. So we are going to have a roller in here, and we are going to have a pinnet connection in here. So we are going to have an X reaction here too, an FX reaction here. So after summation of forces in X, we are going to have 500 pounds here and the reaction in E. So the reaction in E is going to be the same one that we already have in the point A. Knowing this, we can obtain the AY because we already know almost everything in the body diagram. And for summation of forces in Y, we can obtain easily the reaction, the Y reaction in point E. So we already have 650 pounds that we already obtained before. That is the reaction in D. We have the 300 pounds that we already have here. And we have EY, that is the one that we want to obtain. It's very important to be careful with the signs because the sign is going to change everything in the equation. So sometimes in engineering, it's more important the sign than the result. So using a second and a third body diagram, we already have that we can analyze this small member here in order to obtain some forces. So doing a summation of moment in B, in this point here, we can obtain the CY that is going to be affecting in this part. And for sure, using a summation of forces in Y, we can obtain the BY. So we are going to have right now 150 pounds for each one of these pins. Is there any question for this part? Everything is clear? Okay. So after this, we can analyze the other body diagram that we already have here. So we can do summation of moments in A, and with summation of moments in A, we are with the summation of moments in A, we are going to have this small equation here. So we got 150 multiplied by 1.5. That is the reaction that we already obtained before. We got the Bx that is in here that we already don't know. We don't know yet this value here, but we know that we got a distance of 3. And we got 650 that we already obtained here before for D. So in this case, we already obtained a Bx equals to 575 pounds. After this, we proceed to obtain the other forces that are going to be applying in the body diagram that are like this one. So summation of forces in X is going to be these resultants, and we already obtained these values here. So after obtaining these values, we have to obtain the average shear stress. That is going to be done obtaining the value that we already have in here and the area that we're going to be participating in the pin, because as you remember in here, we got this situation here. So the shear that we're going to obtain is going to be divided by 2, because we are going to have 2 planes here. We have 2 shear planes in this part here. So for sure, we are going to have to divide this by 2. So where we were. So the average is going to be obtaining like this one in here. So we got the area of the pin that is here, and we got the shear that we already obtained. This shear is going to be this guy here divided by 2. And this shear is obtained by Pythagoras here. So it's very easy to obtain right now what kind of internal force that we are going to have inside of the element, considering that part. Is that clear? Or is a little bit?
Shear stress, that's a mechanics and materials formula,
yes.
Right? That's not a statics.
Correct.
Yeah, we didn't.
The shear, sorry, what is it?
Just finding average shear strength, average shear stress is a formula from this class. That's not carryover from statics, as far as I remember.
I'm not sure if you saw these equations before, but
not the bottom. The last line
this one?
I didn't see it.
This one in here? Yeah. Oh, well, because we got the stress is going to be equal to force divided by the area.
Okay.
So yeah, the stress is going to be equal to the force divided by the area. So if you want to obtain the shear stress, is going to be equal to the shear divided by the area. So in this case, we already obtained the shear force here, and we divided by the area that we already have. But the shear is going to be in 2 planes because we got a double shear situation. So as we got 2 planes, obviously we have to share the shear between both of them. So it's going to be divided by 2.
Gotcha. That's why we were given the diameter of the...
Correct. So we got the pin right now that is in here.
Gotcha.
Sorry that. We got this pin here. We got the diameter of the pin. And for sure, we got 2 planes here, 2 acting planes of shear here. So we are going to have a shear here, and we are going to have another shear here. So that's why it's divided by 2. For this situation, usually in some exercises, they only use 1 plane. So if there is another question about this, is everything clear? I think this is very, very easy to follow. I'm going to upload this information in the web courses. I'm going to develop another, or I'm going to do another exercise, but we don't have enough time. That is this one here. I'm going to send you a video with this one that is going to be, is going to consist in to obtain the diameters for these, for each cable here. It's very simple, but we don't have enough time. And after that, we are going to have another question here that is going to be on the video that I'm going to upload today. And we are going to have a small homework, sorry, but it's not posted here. But we are going to have a homework that is related with statics, and it's going to be very simple. We're going to be related to the same exercise that we already have, but different situations. So, yes?
And that homework should be next time we meet?
Yes, it's going to be 1 week. The homeworks are going to be 1 week. So it's easier for you, or you are in the first week. So it's just to be sure that you are going to be attending to the class, and just to be sure that how your static concepts are right now. Yes? No, it's going to be on the lab. I'm going to send some announcement about what are we going to do with the lab, because the next lab is going to be the Tensile Test, and it's a destructive test. So I'm not sure how many coupons do we have, and if we are going to be able to be all of us in the lab at the same time. For sure not. I think that the maximum capacity is going to be about 4 or 5 students at the same time in the lab. So I'm sure that I'm not going to have 20 coupons for that test. I'm sure that I'm going to have like 4 coupons or something like that. So maybe it's going to be the only test that is going to be done by myself to all of you, and it's going to be recorded. Some people, if wants to come to the lab, maybe we have to like be sure that we are going to be able to be all of us in the lab. So that's the problem that we already have. I promise you that it's going to be solved this week. But the first task that you have is to make your groups lab. If you don't want to choose your team members, I can do it randomly, as I told you before. And we can arrange what is going to be our schedule in the lab. Is there another question? Okay, perfect. So I'm going to upload a video with the last question that we already have for the statics, and I'm going to upload the small homework that we are going to have. Okay, thank you. Oh. Yes. I'm going to post this in PDF, because right now I use it in PowerPoint that is more dynamic, but I got the PDF for this in order that you can review all the formulation that we already did. This is very easy, and we're going to put in PDF to the one that we are going to do in the video, and the homework is going to be posted maybe today. Okay, perfect. Thank you. Nice to meet you.
¿Qué parte de Colombia es?
De Barranquilla.
Yo trabajo con varios que son de Bogotá y otros de Barranquilla.
Ah, chévere. Hello. Hi. Hello. So we are here. My name is Andres Rodriguez. I'm going to be your GTA for this semester. I'm from Colombia. I don't have enough time for you to introduce yourself in this class today, because we are running out of time, because we had to divide the group in 3. As you can see, we only have 10 chairs here for social distancing. So we are going to know each other during the semester, so we don't have to do it today, so no worries about that. And I'm going to start to knowing you during the semester. So as you can see, first I would like to apologize, because I've been sending emails yesterday about this class and how we are going to handle this, but this is going to be the first class that you are going to have for all the semester, and the modality is very different compared to the last semester. So I wasn't sure that how to let you know that we are going to be only 10 students at the same time in this course, in this classroom right now. This is going to change because we are not going to be having this class very often. We are going to use the lab, but we are going to meet here about 3 times in all the semester, and this is the first time. So for this class, we have 10 chairs. We have 10, the capacity is 10, so we don't have any problem about this. But the lab is reduced, so we have to think a little bit more how we are going to handle this part in the lab. So we are right now here for the Mechanics of Materials lab. I'm going to be your GTA, as I told you. This is my email if you want to reach me anytime, but I'm going to have some office hours. Right now you are section 11. We are going to meet every Monday at 7:30 to 9:20, but we are going to split the hours in order to get a little bit to have the social distances required for the COVID. My office hours are going to be these ones. There are Tuesday between 3 to 4 and Thursday between 3 to 4. But it's very important to consider this, that is going to be by appointment, because it's going to be a virtual office hour. So I'm not going to be able to open the Zoom and just waiting that somebody is going to meet or get the meeting. So if you want to do something, if you want to get some meeting with me, you can send to me an email previously or a couple hours before or the day before, saying that you want a meeting anytime. If you don't have time for these hours, you can send me an email. Hey, I got classes during those hours. Maybe can we meet on a different hour? Yes, of course. I'm very flexible for that. So no worry about this. About the attendance, in this class, as I told you, in this classroom, we are going to have a maximum capacity of 10 students because this social distancing. In the lab, I'm trying to have at least one group per season. So we are going to have, per section, sorry. So we are going to have the group number 1 that is going to be 5 students, and they are going to be able to do the test. After they finish the test, the group number 2 is going to get access to the lab, and then the group number 3. And if we got enough time to do it, the 5 groups are going to be able to be on the lab the same day. If we don't have enough time to do all the tests for all the groups in the same day, we have to figure out what are we going to do. That is where the bend flex methodology is going to, or modality is going to be applied. So some groups are going to have a recorded lab that is going to be developed by me. So I'm going to do the test and I'm going to upload the lab for you in web courses. And some groups are going to be able to do the lab by themselves. For sure, you are going to do some tests, but I'm pretty sure that we are not going to do all the tests. So we are not sure about that. It's going to be up to your time too, because I'm trying to not cover all your time in the lab. So if you have some free hours that you can go to the lab different than these ones, we can arrange something like that, and you can do the test by yourself. Or not, you can do, the other option is that I can record the test and send to you by web courses. We are going to talk a little bit more about these details in a while. So the class assessments is divided by reports. That are the ones that you are going to present to me every week after we do the test. And we are going to have some quizzes and homeworks. They're not going to be too much, so no worries about that. They're going to be just for the lectures like this one. So it's going to be like 3 or 4 quizzes or homework in all the semester. So no worries about this. This is just to be sure that you are going to be attending the class and you are going to understanding the concept that we are analyzing here. It's not going to be a huge deal for this. So it's going to be very easy. And if you have any problem with the homeworks, you can talk to me, you can set an appointment, and we can talk a little bit about the problems. So about the lab reports, it's very important to revise the golden rule that we already have in web courses and UCF web page. We are not going to talk, you have to consider that plagiarism is very dangerous here in UCF. So as maybe you've been knowing on all this time, plagiarism is very complicated. It's a very complicated situation. So try to not do plagiarism the other one. So we are not going to tolerate that part. So do your work by yourself, do your reports with your teamwork, but try not to copy the other ones or not copy the homework of the other guys, because you are going to be considering them plagiarism. The other way that could be considered plagiarism is the citations. That is very important, that you have to cite correctly the authors or the site that you are telling in your report that you are going to use. So don't use by yourself the words that somebody else did. Just give the merit of that person. The report, there is no late submission. So if you submit some report late, we are going to discount or reduce or deduct some percentage of your report according to this small table here. But it means that you have to present the report in 1 week. And if you are late between 0 to 12 hours, obviously you are going to be deducted by 20%. And after 24 hours, well, you are going to be like 100%. Yes?
Is there going to be a report this week?
No. This week we are going to have only a homework that I'm going to explain you a little bit later. It's about static. It's very simple. But the reports are going to start for the other week. So it means that the reports are going to be done for the lab that we're going to do. And the first lab, as we are going to see in the schedule, is going to be for the next week. So no worries about this. What else? Okay, we already talked about the golden rule. And we got this template for the laboratory reports that is well explained in the Mechanics of Material Lab manual that is right now in web courses. This is the Mechanic of Material Lab manual. Right now it's on web courses. You can download it. It's for you. And in this manual, you can see how to do a report. Obviously, you have done a report before, but this kind of report has to be organized with these special topics. There is a small example where you can see how to arrange the topics in the report and what are the most important parts in the report. So try to stick to the plan. So try to do exactly what we have in here, and you are going to be good. So we are going to have a cover page, introduction, equipments, engineering drawings, procedures, measure and data, results, answer to questions. Every test or every report is going to have like 3 or 4 questions that you have to answer. Very simple, are related to the report. So special considerations that some professors saw before. So what do you think about this? Is the young modulus affecting this? Something like that. So the answer to the question is going to be very important. The conclusions about the test, reference that I have to be well cited. So you can use EPA or any method that we know to cite the authors, and the presentation and formatting. That is what we are talking right now. So it has to be very professional and very well designed using these topics that we already have here. Sorry, that's not the homework, for example, by the way. This is the topic that we're going to talk a little bit more in detail. Oh, this is in here. So this is the schedule that we already have. It's in syllabus right now. You can get access to this. This is not the last word that we already have, because this maybe is going to change a little bit because the situation that we already have for the Benflex and for the COVID. So right now we are here, that is an introduction class. where we are talking a little bit about the syllabus, and we are going to talk a little bit more about the statics. We are going to have the first test on lab that is going to be the uniaxial test, and it's going to be done in the lab. The lab is, I'm going to show you in a minute, but it's going to be in the Engineer 2116. So the next class is going to be there. This is just for theoretical classes. We are going to be meeting here for today, for the pre-exam review season, and for the second part of the static review. And we are going to have another one here and another one here. So in conclusion, this class is going to be like a exam preview to prepare yourself for the exam. Not my exam, is the lecture exam that is going to be done by Dr. June. So I'm going to prepare yourself with some exercises. It's going to be very simple. I'm not sure right now if maybe that classes are going to be in here, because I want to cover as much as possible the exercise that are going to prepare you for the exam. Maybe we're going to have 2 or 3 exercises here, and I'm going to post some exercise done by me or by another authors on web courses in order to prepare yourself. And I'm going to do a small presentation and something like that. So I'm going to explain a little bit how to do the exercises. So this is the COVID statement. In this part, well, I'm not going to go deeper in this part. You can read a little bit more about this, but usually, or the most important part here is that you have to keep social distancing. That is something that we're trying to do in these classrooms. You have to use your face mask every time, that every moment that you are here at UCF. You have to wash your hands and everything that we already know. You have to explore a little bit more with this reference. We don't have enough time in this class to go deeper in this, but it's very important to consider the COVID situation right now in order to avoid the risk. In case that you feel sick or something, or you think that you are getting some of the maybe you think that you are going to have COVID or something, you can contact me directly, and you can get access to the classes virtually. So no worries about this. This is the Benflex statement. Is something that I want to talk a little bit more. Right now we are here. We are in this section 11 at 8 a.m. We had to divide the course, as you can see, in 3 groups in order to keep the social distancing. So right now for the lab, we are going to have 5 groups of 5 students each. I'm going to give you the opportunity to arrange your own team members in the 25 students that are in this section, because maybe you know each other's. So maybe it's better if you know your team worker than I'm going to choose randomly. This has to be done this week, before the end of this week, because I have to organize the schedule for the Monday. So if you don't send me your groups, I'm going to choose you randomly, and I'm going to put you randomly in the 25 students that are here. Yes?
The groups out of everyone here in the class.
I'm sorry?
The groups out of everyone here in the class.
I think it's not the same one. I'm not sure, because I think that right now we have some students from Dr. Snyder class, and we have some students from Dr. June class. Mostly this is from Dr. June's class, but I'm not sure. I think this is the same team, the same groups, but I'm not 100% sure about this. You are going to know it in the next class that is going to be with Dr. June, who is going to be on that class and who is going to be in this class. But I think it's a little bit mixed together between both professors and between both classes. So yes, I don't know exactly. But for sure, the 25 students that are going to be in these sections are going to be in this section until the end of the semester. So you can choose the 5 members that you are going to be on your team, but you have time to do it. Otherwise, I have to do it by myself. So the first test, I'm not sure if I told you or was the last group that was here, is going to be a destructive test because it's going to be a tensile test. So we are going to apply a tensile load to, or we're going to apply loads to a bar, and we are going to fail the load, to destroy the coupon. So I'm not sure if maybe the first test is going to be recorded by me, but for sure it's going to be the only test that is going to be all the group together, not the 5 groups. I'm not sure about that. I have to check if we have enough coupons for that, because I'm not sure if we are going to have 20 coupons, because we are going to be 20 groups in total. So I have to destroy 20 bars. So I'm not sure we got enough coupons. So after checking that, I'm going to do an announcement of how we are going to do the first test that we already have in the lab. Is that clear until here? So far, so good? Any questions about this? Nope. Okay. So right now we have a couple of minutes to talk a little bit in detail about statics, the reason that we are here, or you studied before. We already talked a little bit about this part. So the lab is going to be in this place. Oops, sorry. It's going to be in this classroom. Is the Engineer 2. 116, so it's in another building different than this one. All the lab manual is right now on web courses. The syllabus is on web courses, and the only thing that is still pending is to organize the team that are going to be, or the groups that are going to be next Monday, first, the second group, and the third group. So it's up to you. If you are fast in that part, you can organize by yourself. Otherwise, I'm going to do it randomly as soon as possible. So first, we are going to have a small review. This is going to be very simple because you already took static before. But usually, usually we got these 3 types of supports. This is a pin support that is going to develop a reaction in the vertical axis and the longitudinal axis in X and Y. And in 3D is going to develop some torsions in here and a reaction in the FC. Correct? If we are going to talk only in 2D, that is the most simple way to analyze something, we are going to have this reaction and this reaction, vertical and longitudinal, and no moments are going to be in here. For the roller that we have here, it's like we got something over rollers, as the name it says, and we are going to have a reaction in the vertical axis that is going to be Fy. And we got the fixed, that is this one, the fixed support, that we are going to have reaction everywhere. Like we are going to have vertical, longitudinal, transversal, and we are going to have moments in X, moments in Y, moments in Z. Is that clear? This is the basic of static, right? So knowing that principles, we are going to have this small question here, or this small exercise that we are going to develop right now. So we are going to determine the resultant internal loadings on the cross section through the point C in this part here, assuming that the reaction at the supports A and B are vertical. So we got reaction here, right? So first we have to do a body diagram just to know what kind of situation we have here. We got a vertical reaction here, a vertical reaction here. We got a vertical reaction here that is due to the triangle load. And we got a vertical reaction here that is due to the point load. So doing some summation of moments in B, we can obtain AY, the vertical reaction in A, very simple. So we got the reaction multiplied by the distance, that is going to be 4. And we got this movement here, so it's going to be a negative. It depends on the convention that we're going to use, or the notation that you are going to use. In this case, the notation negative is clockwise. So we got this load here that is going to be 6 kilonewtons, that is going to be multiplied by the distance, that is going to be 3.5. And we got the triangle force that is going to be 3 kilonewtons in here. So to obtain the force due to the triangle force is just to obtain the area of the element. So we have 3 times 3 in order to get the total force. divided by 2 because it's a triangle. So it is 3 times 3 divided by 2, multiplied by the distance that we have from the center of application of the load to the point that we are going to analyze the moment. In this case, is 2 because it's going to be applied to 2 times divided by 3. 2 divided by 3, the distance. So after knowing this reaction here, we have to obtain the internal loads that are going to be applied in the point C. So we proceed to do this free body diagram in order to analyze what forces are going to be acting. We are going to have the reaction, we are going to have the punction load here, a shear here, a moment here, and an axial load here. The most easily one is going to be the axial load because we don't have horizontal loads here, so the axial load or the axial internal load is going to be 0 in this case. So when C is going to be 0. So doing a summation of forces in Y, we are going to be able to know what is going to be the shear force in this. So we already have this 7.5 force that is going to be the reaction in A, and we are going to have the 6 that is going to be the point force in here. So finally, we are going to have that VC, that the shear in C is going to be 1.5 kilonewtons. And after that, we can obtain the moment. That is very easy knowing the other forces. So the moment is going to be obtained using a summation of moment in C. We don't know the moment C, that is the one that we are going to obtain. We know that we have a punction force here that is going to be located at 0.5 meters, and we got 7.5 kilonewtons applied in A, located at 1 meter. Doing these calculations, we obtain that the moment in C is going to be 4.5. Is that clear? Any questions? Very simple, right? This is static principles. This is a little bit more complex. So right now we got this element here, this frame here, and we have to analyze what is going to happen in this place here, what is going to happen in this part here. So we have to obtain the average shear stress in each of these pins, considering that the connection in this part is going to be a double shear. You know what is what a double shear is? It's when you got two elements like a sandwich. So you got this one here, and this one here. And this can move like this. So you got two elements here that is going to brace this one with a pin in here. So right now we got that one of these elements for sure is going to be the BC, is going to be this one that has two elements. And this one is going to be the other one that is going to be braced by these elements. So that means, or that's the meaning of the double shear. A double shear has a special consideration. A double shear is going to generate two shear planes here because we got two surfaces. So we are going to have shear here and shear here. It means that the shear that we're going to obtain, the shear force that we're going to obtain has to be divided by 2, right? Because it's dividing the two planes that is going to act in. So the first step is to do the body diagram. That is this one here. Is the simplistic view for this one. We got a reaction here, we got a reaction here. As you can see, this is a roller, but this one is spin. So we are going to have a vertical reaction and a longitudinal reaction in this case, right? Okay. So analyzing the body diagram, doing moment in here, that this is not G, this is E, sorry. We have the force here that is going to be in this direction, so it's positive, multiplied by the distance. We are going to have this force that is 300, that is going to be in this direction, so it's positive 2, and it's going to be multiplied by 3. And we are going to have the reaction in the Y direction, that is in the opposite direction, that is going to be multiplied by 6. So solving this small equation, we are going to have that dy is going to be equal to 650. After that, we are going to do the summation of X forces in the x-axis, or the x-axis. And for sure, we only have 500 pounds here, and we have the reaction in E. So the X reaction in E is going to be equal to 500. It's very simple. You only have one. And for Fy, in order to obtain the reaction in E, the vertical reaction in E, you have all the forces that we already obtained. We have the reaction in D, the reaction, the force in here, sorry, the force in here that is 300 pounds, and that's it. We can obtain 350 pounds in the reaction of E. After that, we have to do the next body diagram, or the next two body diagrams that are going to be this member here and this member here. First, we are going to analyze this member here in order to obtain the forces in these points here. So, doing a summation of moments in B, we can be able to obtain the vertical reaction in C. So we got in this body diagram here, the body diagram of C, we got a force here and a force here. So the first one is going to be Cy multiplied by 3, and the second one is going to be 300 multiplied by 1.5. So we can obtain that the reaction in the Y direction in the point C is going to be 150. After that, we can obtain the reaction in B, the vertical reaction in B, just multiplying, just solving the equation, the same equation that we already have, but in forces. So we got a force in B, a force in C, and the load that is applied in here. So after all the calculation, we can obtain By. So with those forces that we already obtaining, we can analyze the next member that is in here, the member DA or AD. Using the body diagram, we can do a summation of moments in A, and for sure we're going to have right now a force here, and we are going to have a force in here. Sorry, in here, the reaction. So we have 150 multiplied by 1.5. That is going to be, sorry, this one. And we have the resultant X, Bx that is going to be in here that we don't know which one is going to be. So after doing all the calculation, we can obtain the Bx in this direction that is going to be obtaining with the moment, with the summation of moment that we already told before. Is that clear? Okay, perfect. So after that, we can do a summation of forces in X. We can obtain right now the summation of forces in X is going to be equal to 0. In fact, we are going to have the force in Cx is going to be 575. That is going to be the opposite one of this one in order to get the equilibrium inside of the member, right? So to obtain the force in the element, or the internal forces in this point, we have to do this Pythagoras. This one is wrong here. It's just the square root, but we have to do the Pythagoras here, obtaining this value that we already have here. So it's going to be the longitudinal one that we are going to have here, because we got two elements, X and Y. After that, as I told you before, we have a situation when we have a two-shear plane. So we have to divide this resultant force by 2, right? So we got the shear force in here, and then we can obtain the stress. You know that the stress is equal to the force divided by the area. It doesn't matter which force. The force that you are going to use is going to give you the stress that you are going to obtain. So if you're going to obtain the shear stress, you have to use the shear. You are going to use, to obtain the axial stress, you have to use the axial load. In this case, we are going to use the shear stress. You are going to use the shear force to obtain the shear stress. And we got the shear force that is going to be this one, that is this guy divided by 2. And the area is going to be the pin area that we already have in the statement. So with these values, we can obtain right now the average stress, shear stress in that point. So is that clear? Sure. Do you have any question? Okay, perfect. So this is the last exercise that I can do today. I'm going to do 2 more exercises like this one that are going to be posted in the web courses. I'm going to do a video for these ones to explain a little bit deeper in this part. And with that exercises, we are going to have 3 questions. It's going to be 3 more exercises that are going to be very similar to these ones for homework. So it's going to be 1 week. So you can present the homework for the next week, and that's it for the next week during the class. You can submit it by web courses. I'm going to send to you all the considerations in order that you are going to be able to finish the homework on time. If you have any question about the homework, you can contact me and I can solve to you, or we can solve together what is going to be the problem. And hopefully you are going to be able to finish the homework. The homework, the idea of the homework is to know how good you are right now in statics. It doesn't matter if you are going to learn a little bit more, but I want to know how good you are in static in order to be able to show you the next test that we are going to have, or to know the concept that you have for the test.
And we're submitting that online?
Online, yes. Mm-hmm. Okay, so that's everything for today. If you have any question, no questions, okay. If you have another question after you are reading the syllabus online, you can reach me by an email or something. Okay, thank you.
Yes.
Bye. Hello. It seems that you are the last 2 ones. Okay. My name is Andres Rodriguez. I'm going to be your GTA for this semester, and we are here for Mechanic of Material Lab. So first, I would like to apologize for all the emails that I've been sending to you yesterday at the end of the day. But this modality is new for the university, is new for us, and this is the first class that you are going to have, and the interaction is have to be done before the class starts. So
All right, I'm supposed to be in measurements, so maybe I went into the wrong classroom.
in what, sorry?
I'm supposed to be in measurements. I've taken the class, so I must be in the wrong place.
Okay.
So if I'm in group 3, I'm supposed to be at 8:40, right?
Yes.
Okay.
Yeah, the problem is that we're 25 students, but this is going to change very soon because we are 25 students. I have to divide the group in 3, the class in 3, because the capacity of the classroom is 10. I just took randomly the first 10 students that are going to attend and the second 10 students. You are supposed to be a group of 5, but you're alone. But we can change these things right now. But no worry, this is because this is going to be the lecture class for the lab, but the lab is going to be different. The lab is going to be in your group. So you are going to be in a group of 5. I'm going to explain you a little bit more about in detail for that part. You are going to be in a group of 5. We are going to have 5 groups for the lab, and each group is going to be the one that is going to be attending the lab directly. So you are going to be in the lab with your team members. Okay, so my name is Andres Rodriguez. This is my email that for sure you already have it because I sent an email to everyone yesterday. Hopefully everyone received the email, and I send the announcements in the email, in the web courses. Good morning.
Good morning.
So right now you are in section 11. The class is going to be between 7:30 to 9:20, but the problem that we already have is that the classroom capacity is for 10 students only. So I had to divide the group. That's a band flex modality that we already have right now for the university for this semester, the coronavirus situation and the social distances that we have to keep right now. But I'm going to explain you a little bit more in detail about this classroom and about the lab, because this classroom is going to be only 3 or 4 times. We are going to use this classroom 3 or 4 times. The other class are going to be on the lab because our class is a lab. But we are going to have some theory classes like this one and some reviews for the exams that are going to be before the exams, obviously. in order to prepare you a little bit more for the exam that is going to be done by Dr. June or Dr. Snyder, depending on the professor that you already have. So my office hours are going to be virtual, are going to be on Tuesday and Thursday between 3 to 4. If you have classes between 3 to 4 in these days, I'm very flexible for this, and you have to reach me. You can do an appointment by email, and we can arrange 1 hour for a meeting, for a virtual meeting. For these hours, obviously, it's very important to do it by appointment too, obviously, because I'm going to do it by Zoom link, and it's going to be very odd that I'm going to send the link and I'm going to be waiting 1 hour that somebody is going to be connected to the appointment. So it's better to do it by appointment. The attendance, we already talked a little bit about this, and we are going to talk a little bit more in detail for the attendance in the last statement of the syllabus. The class is going to be organized for the lab in groups of 5, and the reports are going to be, the class is going to be divided in the following assessments. We are going to have lab reports that is going to represent the 90% of this class, and we are going to have quizzes and or homeworks that are going to represent only the 10%. These homeworks are made to know that you are that you are assisting to the class, that you are getting the concepts, and it's going to be in order to know how deep you are in some topics, like, for example, in this case, the static review. We are going to have some questions about the static and some problems about the static, and it's going to be very simple in order to be sure that we are going to be working on the same page. Because if we are going to talk about stresses, or if we are going to talk about forces, I would like to be sure that we are on the same page. So the reports are going to be presented every week after the test. So we are going to do the test on the lab, and you have a week to prepare the report. No late submission is allowed. So if you are going to submit late the report, obviously I had to deduct some points from the final grade that you are going to have. It's very important that the report consider this special place here, or this special phrase here. There is no tolerance to the plagiarism, so no cheating, no copy to the other report or some older report, no copy the homework to the other students. There is no tolerance for the plagiarism, even for the citations of the report. If you are going to say something that some author said before or somebody said before, you have to cite it correctly. You have to cite it using EPA or another method for references or citations. So it's very important that, obviously, I'm not going to say that you are going to fail the report because you cited wrong somebody, but it's going to affect your grade. So it's better that you do it professionally, citing correctly with the requirements for each method that you are going to use for the citations. The academic integrity, we already talked a little bit, but actually you have to check for the golden rules. I think if you've been a student here before, you know it is in deep detail. But if you have some question about the golden rule, you can check here the link that we already have. So the laboratory reports are going to have this special task or these special chapters. These chapters are well explained or explained in detail in the laboratory manual that we already have right now in the web courses. I already posted yesterday at the end of the night, but you have access to this manual that is around 50 pages, I think. Is very detailed, but right now we are going to focus in this part. It's the same table that we already have, so we are not going to change in the value between the syllabus and the manual. We have a cover page, introduction, equipments, engineering drawings, procedures, measurements, and data, results, answers to questions. There are some questions that we are going to do that you have to answer related to the test. So, for example, is the young modulus affecting the results of something in the test? Something like that is going to be 3 or 4 questions. The conclusions about the test, references, and presentation and formatting of the report. So all of this has a weight inside of the grade. So it's very important that you pay attention to this, to stick to the plan in order to be sure that we are going to be working on the same page for the report. The report has to be presented professionally. So it's not something that you have to do very fast on the Sunday night. No, it has to be something very, very professional. This is the schedule that we are going to have. As I told you before, we are here right now for an introduction, that is the syllabus, and for the static review. We are going to have the lab meetings that are going to be here, and we are going to have some meetings in here that are going to be done for the pre-exam, for another static review, another pre-exam session, and another pre-exam session. Maybe this one, the last one, maybe it's going to be online because it's after Thanksgiving. So maybe we are going to do it online because a lot of students are going to be traveling outside of the state, and maybe they are not going to be able to return until the final exam or something like that. So I prefer to do this one online. I'm going to be here but nobody knows who is going to be out. The other important consideration is about the last test that is going to be matching with the Thanksgiving date. That is going to be the last Thursday of this week, sorry, the Thursday of this week. So I'm not going to ask you to present the report on Monday. So it's going to be presented a little bit after the day, because just to give you the Thursday, Friday, and the weekend to share with your family. So, but it's something that we can talk. This is not the last word. We can change this a little bit, and for sure it's going to be changing because this bend flex situation that we already have, that is going to be the next topic that we're going to talk. So we already have the COVID statement inside of the syllabus. Obviously, to summarize this, you have to notify if you feel that you are having symptoms of COVID. You have to raise the hand and say, I can't go to the classroom today because I'm not feeling well, because I got these symptoms, and we can do it online. So we have to keep the social distances that we already have here. So 2 meters, that is very important to have, the 6 feet. And obviously use the face mask every day and every time that we are inside here, the room, and inside the university. For more details about this, you can check a little bit deeper in the syllabus, and you can check the links that are in here that are related to the web page in the UCF web page. We got here the bend flex statement that is related to how we are going to handle the classes, because we are 25 students and the classroom only allowed a maximum capacity of 10 students. The lab, I think, is 5 or 4, I'm not sure. So for the lab, it's very important that you arrange or you create your group, your team members for the group. Letting you the option to do it by yourself, but if you don't confirm me your group before this week, for sure I'm going to do it randomly. So you have a deadline for that. I'm going to do the announcement for this, because the next week we are going to have the first lab. So the first lab, we have to have the groups to get access to the lab and to obviously work on the report. So you are going to have a few days to organize yourself. I'm going to do the announcement today, how much time we have to arrange the group. If you don't want to choose your team member, I'm going to do it randomly. So no worries about that. So everyone is going to have a group here. So no worries for this. And it's going to be a group of 5. So I prefer that you choose your team member because you have been working with them all these semesters and you know each other. So it's good, it's better for you. For me, it's easier to choose randomly. That's it. Okay. We're going to have 5 teams of 5 students each. The only test that maybe is not going to be done by yourself is going to be done by all the 25 students, or maybe a recorded session is going to be the first test. We are not decide. I didn't decide how to do with the first test because it's a destructive test. If you can see here, maybe you are going to learn a little bit deeper we are going to learn a little bit more about this, but the tensile test is a destructive test. So we are going to take the bar, we are going to apply the loads in the corners, on the corners of the bar, and the bar is going to break. So I'm not sure how many coupons do we have for the test, but for sure I don't have 20 coupons because we are 20 groups. For sure I'm going to have maybe 4 coupons, 6 coupons. So maybe I'm going to have a coupon per section, or maybe I'm going to have a coupon per section and some extra coupons. I'm not sure. I have to analyze that part. I have to ask that to Mr. Lee, that is the manager of the lab. So it's going to be announced this week. But first thing first, we have to make the groups. So you have to choose your team members as soon as possible. So the access to the lab is going to be announced by web courses. If we found a simple way to solve this problem, is going to be a new syllabus or a new schedule is going to be attached to the syllabus for this part for the lab, directly for the lab. But right now, the idea that I have is that some of the groups are not going to be able to do all the tests because we are not going to be able to be 5 groups in 2 hours in the lab. So the tests are going to take maybe 20 minutes to 30 minutes. So maybe we're not going to be able that 5 groups are going to develop each test. So maybe we are going to record some videos for the groups that are not going to be in the test, and the groups are going to be randomly selected, but you are going to do tests on lab, but not all. Is that clear? Okay. So right now, we're going to do a little bit review about statics. Is that clear about the syllabus? Is anything that maybe you have any question about the syllabus? It's a little bit complex today because we are in a different modality right now, but for sure it's going to be easier to follow the syllabus or follow the class after the next week. But if you have any question, you can do it right now, or maybe you can email, no worries. Okay. So our lab is going to be in this room. It's going to be in Engineer 2116. Is another building that is in the other building. You know, if you know where is the lab, that's good for you. If you don't know it, it's going to be in Engineer 2116. Is in the other building. So talking about static. We are going to talk a little bit more about the supports or the common supports that we already have for the structures. For statics, we know that we have the pin support, roller support, and fixed support, usually. But we have some modifications of some links or some kind of support that are going to change a little bit the behavior of the original supports. But essentially are these 3. So we got the pin support that is going to develop a reaction in the vertical axis and a reaction in the longitudinal axis in 2D. If we are talking in 3D, we are going to have another reaction in the FC because it's pinned in that direction. We are going to have moments in the longitudinal and the transversal axis if we are talking in 3D. But we are going to be free to move in this moment in here. Is that clear? So for the roller, it's like we have some wheels in the ground, and it can move in every place, to every place, to free. But the only one that is going to be supported is the vertical axis. So the vertical axis is going to support the element in order that the element is not going to fall down, but it can move free in the other directions. For the fixed support, we are going to have moments and rotations in every place. So we are going to have a reaction in the Fx, reaction in Fy, reaction in Fc. We are going to have rotation in X, rotation in Y, and rotation in C. So it's the most complete support that we already have in the structures. So knowing that, that is the basic of the static, or at least for the elements, we're going to analyze a little bit some problems that we already have here. So the first one, that is the easy one, is determine the resultant internal loadings on their cross section through the point C. Assume that reactions at support A and B are vertical. So it means that these are just a reaction in this point here. So we have some kind of rollering in this place. So the first thing that we have to do is to elaborate a body diagram for the element. That is this one. The body diagram is something that is going to summarize every load and every reaction that is working on the element. So we got a reaction here, we got another reaction here that are verticals. We got the punctual force equal to 6 kilonewtons in this point, and we are going to have a triangle force that is going to be done by this the figure that we have here. So this triangle is going to be 3 kilonewtons at the top, and we are going to have 0 kilonewtons in this part. So first we have to analyze what is going to happen with this figure to obtain the reactions. The first step is to do a summation of moments here that for static is going to be equal to 0. Everything has to be in equilibrium. That's one of the first principles of the static. Everything is in equilibrium. So we have summation of moments in B that is going to be equal to 0. We are going to have a force in AY that is going to be clockwise. In this notation is going to be positive. So, negative. So we are going to have this, this force here multiplied by the distance, that is 4. We're going to have the punction force here, that is 6, multiplied by the distance, that is 3.5. That is this number that we have here. And we are going to have the triangle that is going to be the area of the triangle applied at 2 divided by 3, the base of the triangle. In this case, we are going to have to apply the load in here that is going to be 2 meters of distance between the load and the point B. The area of the triangle is 3 multiplied by 3 divided by 2. So we got the area of the triangle here, and we have the distance between the force application to the node B. After solving that equation here, we are going to be able to know that the reaction in A is going to be 7.50 kilonewtons. Knowing this, we can do the next body diagram in this part in order to know the forces that are going to be working on this point. So we are going to have a reaction here that we already know because we already obtained it in here. We are going to have the force that is here, and we are going to have a shear, a moment, and an axial load. So first we have to obtain the axial load that, as we know, we don't have horizontal loads in here. Therefore, we have that NC is going to be equal to 0. We don't have any vertical, any horizontal loads here. For Fy, we can do a summation of forces in order to obtain the Fy. And easily we can obtain that 7.5, that is the reaction, minus 6.5 is going to be equal to VC. So we already have that VC, that is the shear in the point C, is going to be equal to 1.5. After that, we have to do summation of moments in C, that in this case is going to be equals to 0. So we are going to have 3 acting moments here. The moment generated by the reaction in A, the moment generated by the force or the punctual force, and the moment in C. That is going to be the opposite one to get the equilibrium in that point. So we already have moment in C, 6 multiplied by 0.5, and minus 7.5 multiplied by 1. So in this case, we got that the moment is going to be 4.5 in this point here. Is that clear? Any question? Very simple. Okay, perfect. This is going to be uploaded in the web courses too, so don't worry if it's not necessary that you take notes or something, because it's going to be the same slide that you're going to have here is going to be on web courses. Okay, so this is a second example.
Recording as well, right?
And the recording, yes, but I'm not sure how it's going to be the recording and how good is going to be the recording, because this is the first time that I'm recording a class in Zoom. I used to see the recording classes in pan up video, and it's very clear, but I'm not sure if, I'm sure that we are going to be showing this presentation, but you are not going to be able to have my face-to-face interaction with me, but you are going to be watching this presentation right now. So for the question number 2, we got this frame here that is going to be subjected to a double shear in the pins. Do you know what is a double shear? No? The concept of the double shear is that you are going to have a member that is braced with another 2 members and is going to have a pin here. So the member is going to be able to do like this, and it's going to be in the middle of these ones. It's like a sandwich. So you're going to have a member here, you're going to have this one in this, and the other one is going to be in the opposite, in the other side, and you are going to put a pin in here. So you are going to develop a double shear area here. It means that you are going to have a shear area here acting over the pin and another shear area here. So you are going to have two plans of shearing. That's the concept. And it's important for the end of the exercise that I'm going to show you. We know that the diameter of the pin is going to be 0.25, and they are requesting to determine the average shear stress. Do you know what is the concept of the shear stress? The shear or the stress. The stress is going to be the force divided by the area. So it doesn't matter what shear you want to obtain. The only thing that matters is what force do you have. So if you are going to obtain the axial shear, or the axial shear is going to be done by the axial force divided by the area. In this case, that is going to be the shear stress. Sorry, the axial stress. Sorry, the axial stress is going to be the axial force divided by the area. In this case, we have the shear stress that is going to be the shear force divided by the area. So knowing the area, that is this, that we get the diameter, we can obtain the area of the pin, the cross-section area, and knowing the shear force, we are going to be able to obtain the shear stress. So right now, we are going to work with the first body diagram in order to obtain the resultant forces in the nodes. As we can see, we got a pin here, sorry, a roller here, and we got a pin here. So we got a vertical load here, a vertical reaction here, and we got a vertical and longitudinal or horizontal reaction here. So first we have to do moment on E. This is not G, this is E, sorry, it's a typo. And we are going to have a force here equals to 500 pounds. We are going to have a force here equals to 300 pounds. And we are going to have the reaction here that is going to be an unknown value multiplied by the distance. So we are, for the moment, so we are going to have the summation of moments in here, and it's going to be 500 multiplied by 6. That is the height that we already have. We are going to have 300 multiplied by 3. And we are going to have the reaction multiplied by the distance, that is going to be 6. Solving this equation, we are going to have that the reaction in D for the y direction, or the vertical direction, is going to be equal to 650 pounds. After that, we have the summation of Fx, that if we can see here, we are going to have only this reaction, this load here, and the reaction. There is no more elements in the horizontal axis for this body diagram. So right now we know that the reaction in E is going to be equal to 500 pounds. After that, we are going to do the summation of forces in the vertical direction, that it has to be in equilibrium equals to 0. We have the reaction that we are already obtaining here, that is 650. We have these 300 pounds that is going to be acting in the opposite direction, and we have this reaction here that we don't know. Solving for EY, we are going to obtain that EY is going to be equal to 350 pounds. Is that clear? Any question? Okay, perfect. So next, knowing this value that are the reactions of the element of the frame, we are going to analyze two different body diagrams. So each body diagram is going to summarize what we are going to search, or the element that we are going to analyze for the force that we want to obtain. So in this case, we are going to analyze this body diagram, this free body diagram, that is the simplest one, that is going to be this element in here. And doing a summation of moments in B, we are going to be able to obtain the reaction or the force acting on C, because we already have this force here and we already have the force in C. So we got 300 multiplied by 1.5, and we got CY multiplied by 3. Solving for CY, we are going to obtain 150. Same thing here. We are going to do summation of forces in Y in the Y direction, and we already have BY that we don't know it. We have 150 in BC in point C, and we have the 300 pounds that are acting in this direction. So we solve for BY, and we obtain that BY is going to be equal to 150. Is that clear? Okay, perfect. After that, we are going to analyze the next body diagram, that is going to be this one. So we are going to analyze the summation of moments in A, that is in this point here, in order to have the forces in vertical and horizontal in this case, to be sure that we are going to be able to obtain the force that is going to be acting in the member, because we already know the vertical load that is going to be applied on B, but we don't know what is going to be the horizontal load right now. Knowing those forces, we can obtain by Pythagoras the force that is going to be acting in this direction, in the diagonal. So first, doing summation of moments in A, we are going to be able to obtain that we have 150, that is the one that we are already obtained in B, right, in this direction, positive. We are going to have the BX that is going to be working in this direction, multiplied by 1.5, that is the distance that we already have. Sorry, by 3, that is the distance that we already have. And we are going to have this reaction here, that is the one that we already obtained at the beginning, that is the reaction in D for the vertical direction. Solving these values, we are going to be able to obtain BX. So we are going to have right now a reaction in the Y direction and a reaction in the horizontal direction for this point. But we need the internal force, or the internal force that is going to be developing in this direction, in the horizontal direction. So what is the simplest way to do this? Is doing Pythagoras. So doing by Pythagoras, this is the square root. There is a typo here. So this is the square root of these values here that we already know for the previous calculation. In fact, we are going to be able to obtain this value here that is going to be the diagonal that we already have here. So that's going to be our shear force applied in this point. But what about the shear stress? So as I told you before, the stress is going to be defined by the force divided by the area. So we got this. You know that tau is going to be the shear stress, you know that, and sigma is going to be the axial stress. You know that? No? Okay, well, this is tau, that is going to be the shear stress. Is the letter, the Greek letter that is going to represent the shear stress, and the axial stress is going to be represented by sigma. In this case, we are obtaining the shear stress, that is going to be the shear force divided by the area. And for sure, we know that this is the shear that is acting in that point, but we're condition of double shear, the double shear that I already explained to you before, that is going to be the one that is like this one. We're going to have two planes acting in the element. So as we have the two planes, we have to divide by 2 the shear that we already obtained, because we are going to put the shear in the two planes. So the two planes are going to be working with that. We are going to have two cross-section areas working in the pin, because you are not crossing the pin directly, you are crossing the pin in 2 areas, in two sections. So we are going to have 2 section areas. So the shear is going to be divided by 2. In this case, is this value that we already have. And the area of the pin, of the cross-section of the pin, that is going to be in here. Solving this equation, we are going to obtain that the shear stress is going to be equals to 6.05 KSA. Is that clear? Do you have any question about this? No? Everything's clear? Okay. I got another exercise, but I think that we don't have enough time to solve it. Let me check. Yeah, but I'm going to post a video with these exercises, because there is another one that is going to be done, that is this one. And then we are going to have the homework that is related to these topics. That is very simple. I'm going to post these slides on the web courses, so you are going to have access to these slides anytime you want, and you are going to have access to the video. The homework is going to be announced today, and is going to be due to the next week for the class hours. So you can submit the homework on Sunday or Monday 7:30. So it's better to submit on Sunday. It's going to be very simple. If you have any question about the homework or how to solve any of these problems, you can email me and we can solve any issue that you have. Okay, perfect. Do you have any question about anything about the syllabus, about the static? No? Yes?
The lab, when we work in groups,
Yes.
it'll be groups of 5, right?
Correct.
We don't have to distance ourselves.
We have to, that's
within the group.
In the group, we have to keep the social distances. Not sure 100%. Maybe I'm going to be the one that is going to be handle the experiment in front of you, and you are going to be watching the experiment. Maybe one of you is going to be the one that is going to do the experiment, because the first one is going to be developed by me, but the second one is just to put a bar into pins, and we are going to force to apply torsion in the bar in order to obtain the shear force. So it's a small equipment like this one. So maybe one person is going to be able to manage the equipment, and we are going to use 3 bars. One is copper, the other one is aluminum, and the other one is steel. So you can choose your team member that is going to be the one that is going to bend the bar. The other one is going to be the other one that is going to play in the other torsional force, and the other one is going to play with the aluminum. Some of you is going to be the one that is going to be taking notes, and the other one is going to be someone that is going to help. Not sure, it's going to be something like that.
There's going to be designated times per group.
Yes. Yes, but obviously if you didn't finish, I'm not going to take you out. Or, I mean, you have to take the time that you need to finish the test. It's not an exam. It's not like if you didn't finish in 20 minutes, you are going to have 0. No. We are working at your speed. If there is not enough time for all the groups to do the test, I'm going to record the test, and it's going to be updated in submitted on syllabus, updated on syllabus, on web courses, or maybe we can arrange another hour to do the test in the lab.
How are we going to know if there's not enough time for the groups to complete it?
How we are going to know if there's not going to be enough time? Because we are going to organize, I know how long is going to take the test. Around 20 to 30 minutes is going to be each test. It's something that I have on mind. On my experience, is going to be a maximum of 30 minutes. So if we arrange the groups that are going to be meeting at 7:30, the other one is going to be at 8, the other one is going to be at 8:30, the other one is going to be at 9. The group that is going to be at 9, if they have enough time to do it until 9:30, that's good. But there for sure is going to be a remaining group that is going to be doing the test in after hours, or doing by recording, or maybe we can arrange groups of 6 or something like that in order to be everybody in the same at the same time doing the test in different hours. So it's something that is not 100% clear, but it's something that we have to figure it out with the band flex that we already have. But it's going to be solved this week. I promise you that everything is going to be solved on this week. So I have to talk right now with Mr. Lee, that is the manager of the lab, in order to be sure how many people can access at the lab at the same time. I'm going to check the labs, the testing machine, in order to be sure that we are going to be able to do something, because everyone wants to do something in the lab. Otherwise, it's the same than a book.
Yeah.
Okay, perfect. Thanks to you.